Hey guys, let's take a minute to review the elimination method, otherwise known as linear combination. Okay, there are three kind of types of challenges we can see with the elimination method. Let's go over the first one, the most basic. So remember, we use this method when we have two equations that are in standard form, meaning our x's and y's are all lined up nicely and our constants are on the other side. In order to use elimination and to be able to add vertically, we need to have opposites. So right away, I'm looking at my x's. I don't see any opposites, but I do see opposites with my y's. I have a positive y and a negative y. Okay, what that means is when I add vertically, my y's are going to cancel, which is the goal. We want to be able to cancel out one of the types of variables. So when I add these, 1x and 1x is 2x. Positive y and negative y are going to cancel out. 4 plus 8 is 12. Now I can easily solve for x. I do that by dividing 2 on both sides, and that's going to give me half my answer. So remember, when I'm solving a system, I'm looking for the x and the y coordinate. So after I get the x, I have to choose one of the equations to substitute my answer back into to solve to the other variable. I'm going to look to my first equation, x plus y equals 4, because my y value is positive. Again, it doesn't make a difference. You could use either one, but I'm going to use the first. So if I have 6 plus y is equal to 4, I'm able to solve for y pretty easily by subtracting 6 from both sides. That's going to give me a y value of -2, which should be the answer to my system. Remember, I can always go back and check my work by substituting the coordinate point back into both equations. So just by using some quick mental math, 6 plus -2 is 4, and then 6 minus a negative 2 is going to change this to a +2, so 6 plus 2 is 8. So that checks out. Okay, that's the most basic. The next challenge, and I'll call this the medium challenge, is when it looks like we almost have opposites, so my numbers are the same and my variables are the same. Our issue here is that our signs are not opposite, they're the same. Okay, so ideally I would like one of these d's to be positive. Okay, so what I'm going to do, and I could choose either equation. Remember, mathematically we can do whatever we want to anything in an equation as long as we do it to both sides. So if I want this to be negative, mathematically, I'm going to multiply everything by -1. Okay, sometimes it may help to draw your little loops in so you don't forget about any of the terms. That's going to change this to -5c, positive 9d, and -103. Okay, I'm just going to rewrite the second equation underneath just so I can kind of see it combined. Okay, now I have my opposites. So once I have my opposites, I'm going to go ahead and I'm going to add vertically. Just change colors so you can see this a little bit more clear. Okay, so when I add vertically, -5c and 6c is 1c. My opposites are going to cancel out. -103 and 111 is 8. Okay, so again, that's my C value. This one's a little bit different because we're used to seeing X and Y. So I could leave my answer as just C equals and then D equals. If I was gonna write it as a coordinate point, a rule of thumb is you would write it in alphabetical order. So our C would go first. Okay, I'm gonna solve for D. Let's see, it doesn't really matter which equation I'm gonna use. I'll pick the second one. So 5C minus 9D is equal to 103. So again, I'm just using substitution. So I've solved for C. Oops. So that means I want to substitute my C value with 8 because I said that C is equal to 8. And then now I'm just going to go ahead and solve. Okay, so now you're just solving just like you would any other equation. Oops. I'm running out of a little bit of space. So D is equal to -7. Okay, and again, a good rule of thumb is to go back and check your work just to make sure we did all our math correctly, so we can go back and check that. Okay, the last type of elimination problem, and I would say this is probably the most complex, is when I'm looking at my x's, and these numbers aren't the same. I don't have opposite signs. Same thing, I don't have opposite signs, and my numbers are different. So the first thing I would probably ask myself is, can I multiply one of the equations to get an opposite of the top number? So for instance, can I multiply 3 by anything to get 4? Nope, I can't. I can't multiply 2 by anything to get 3. So what that means is instead of just having to multiply one of the equations to get opposites, I'm going to have to multiply both equations by different numbers. Now, this is where you have a couple options, okay? If I wanted to eliminate my x's, an example could be I could multiply by -3 and +4, okay? You can kind of flip-flop the numbers and make sure one of your signs is negative. If I was to do that, I would end up with -12x and +12x. That would be opposites. Another option is I could multiply by 3 and -4. This would give me a 12x and a -12x. That's opposites. Another example, I could multiply the first equation by 3 and the second equation by -2. My x's wouldn't cancel out, but in this case, my y's would. I would end up with 6y and -6y. I could do the same thing, keep a negative here. This is going to be -6y and +6y. So there are lots of different options here. I'll stick with this last one. So again, I'm going to multiply the entire top equation by -3. And again, mathematically, I can do that as long as I'm multiplying every single term. So that's going to give me -12x minus 6y is equal to -24. Now my second equation, I'm going to multiply all the terms by 2. So there's 6x, +6y, and 18. So again, remember my goal is to make sure that I have opposites in either the x's or the y's, so one of the variables cancel out. In this case, I can see that my y's are opposite, so once I see that, I can go ahead and add vertically. So -12x and 6x is -6x, -24 and 18 is -6. Okay, and then again, I can solve easily for x now by dividing by -6. Now, in order to solve for y, okay, I need to choose one of these equations to substitute my x back into. So as a rule of thumb, I always like to go to my original equations because my numbers are smaller. So I could use the new equations, but I'm going to have some bigger numbers to multiply. So I'm going to take an x and looking at these, I don't know, I'll plug it into my second equation here. So this would be 3x plus 3y is equal to 9. Again, if you wanted to choose the first equation, you could do that. Okay, my x is equal to 1, so I'm going to substitute a 1 for my x value. And then I'm going to solve for y. So I would subtract 3, kind of running out of space, so I'll shorten that and then divide everything by 3. So my y is going to be equal to 2. Okay, so I could leave it like this, or I could write it as a coordinate point if I wanted. And then again, to ensure that I did this correctly, I could go back and check my work. Please make sure you're copying this into the foldable, and you can go back and review this anytime you need.